In this video, I wanted to go over this problem, which will allow us to use the junction rule several times. It asks us to find the current at point A. So what's the current going through this resistor and through this wire right here? We are given the current I1 here, which is 6 amps. So if that's I1 in this wire here through this resistor, that means that's the same current here, I1, and it's the same current going to the right here. You must have that same current in that whole left wire here. It's just one wire. The current does not split up anywhere. So if we have I2 here in this vertical wire, that means that that's the same I2 that's going through here. Again, this is just one wire. It must have the same current. So what we can do is we can use the junction rule at this junction. We could also pick the top junction, but I prefer to use the bottom junction because it's just easier based on what we're given later. So we have I1 going into the junction. We have I2 going out of the junction. So we know that there has to be a current here, either going into or out of the junction. Usually you just write it whichever way you want, and if it comes out to be negative, then you know that you wrote it in the incorrect direction. So for example, if I wrote I4, let's call it, if I wrote I4 to go to the right here, when I use my junction rule, the currents in would just be I1. That would be the current in, and that has to equal the current out. And we have I2 and I4 that are both coming out of this point. So if you do it that way, and then you solve for I4, that's what we're looking for, then you'll have I4 equals I1 minus I2. Plug in what you're given. We're given 6 minus 11, we get -5. So that tells us, since we get a negative current, that we drew it the wrong way. So what I suggest in this case, because we're just doing one junction at a time, is to not write it this way and actually realize, well, if we have 6 amps going in here and we have 11 amps going out here, then we must actually have 5 amps going in, because 5 plus 6 will equal the 11 that are going up here. So what I would have done, even though you could do it this way and then realize that, okay, the current's actually going in, what I would have done is just written it this way to begin with and said, okay, well, 6 plus this unknown current here, I4, must equal the current coming out, which is I2, which is 11. And that just tells me, okay, I4 must be equal to 5 amps. And then we can look at this junction over here. We know that I4 is going to the left here because it's the same current through this little segment of the wire. So I4 is 5 amps to the left. We've got 20 amps going to the right here. Both of these currents are coming out. So that means that there must be a current going down here, because that current is splitting up into 5 amps and 20 amps. So just analyzing it this way, you can already say, well, that means that this current going down here must be 25 amps. But if you didn't know that, you can go ahead and write the junction rule for this second junction here, call this I5, and if you happen to draw it downward, then you would say, okay, the current going in, which is I5, equals the current going out, which is I4 plus I3. And then you can see that your I5 will equal your 5 plus your 20 amps to give you the 25 amps. So just to recap, this problem was just to get you guys used to using the junction rule. You could actually do it in your head without really needing the equations in this case. But a reminder that if you have no idea which way the current is going, then just stick with the direction, and if it's negative, you drew it the wrong way. So you can stop the video here, or if you just want to listen on to one more thing, what if you originally had decided that I4 was going to the right. That's what you thought, right? So then, how do you keep solving the problem? Well, if you decided that I4 was going to the right, then you got a negative answer for I4. You got -5. So then what you do is you then still randomly guess a current direction here. Let's say you have no idea which way the current is going, but let's just assume it's going up and call I5 going up. Okay, so now we're just random guessing, but now we have to write the junction rule based on what we wrote down. So what's coming into the junction is only I4. So I in is going to equal I out. What's coming out is I5 plus I3. So you just have to be consistent. If you're sticking with the current going to the right here, which is a negative value, even though it's really going to the left, but you kept your arrows to the right, then you have to keep the actual value that you got for I4, which was -5. And I5, and then I3 is 20. And then when you solve for I5, you subtract 20, you get -25 amps. So you're consistent with your arrows, even though we guess both of these arrows incorrectly. By being consistent, this negative sign just tells you, okay, I picked I5 to go in the wrong direction. I5 is actually going down. I picked I4 in the wrong direction. I4 is actually going to the left. I hope this helps everyone.